All right, so in this question, I'm giving the average of a random sample of a size of 53. The average is going to be 3850, and I'm giving as well the population standard deviation, which is 615. And I'm required to find the 98th percentile confidence interval. All right, so let me get into the whiteboard. Okay, so here, just to make it clear that we are dealing with n equals to 53, all right, I am giving the x bar, which is 3850, and I am giving the sigma, all right, sigma is going to be 615. This is the population standard deviation, so sigma is known. And we know every time sigma is known, I'm using the z-scores, right, or z-table. Okay, so just to make sure that I'm using the z's, right? So now what the problem is, we have, once we sample, so once we found with the sampling here, once we are done with the sampling, which is n equals to 53, we have the central limit theorem is telling us that the new distribution is going to be a normal distribution. All right, so this normal distribution is going to have a new, all right, so this is going to be called, by the way, the x bars, right? So that's where we're going to put this. So we're going to have a new mean, which is called mu x bars, all right? And we're going to have the sigma x bars. So the sigma x bars is going to be the old sigma divided by radical n. So my sigma here is going to be 615 divided by radical 53. So I need this number, all right? So I need this one. And as well, we don't know this mu x, so we are doing the 90th percentile. So what does mean the 90th percentile? So what will be the 90 percentile here, the 90%, all right? If I have a 90% of the data in here, all right, what will be my lower value of the x, all right, x lower, and the x upper here, all right? So I am looking for these two values. Now, how can I do this one? So what we're going to assume, we're going to assume this value here in the middle. So let me change it. All right, so we're going to assume the value x bar in the middle, which is equal to 3850, and we're gonna look for these two values, right? So this one and this one. Now, in order to do this, I need obviously these two tails. So I need the tail here, all right? So this is the tail I need, and this tail is gonna be whatever remaining from these two, that's another tail. So you see here, this tail, the left and the right, they are equal to each other. So if this one is 90%, all right, c equals to 0.9. We have a formula here. This will be 1 minus c divided by 2. All right, if you plug it in, it's going to be 0.1 divided by 2, which is 0.05. Similarly here, 0.05. So now, why do I need this? It is, all right, the reason I need this, because I'm going to use the calculator, and the calculator is going to ask me about the area, the left tail area. So if I want to find this number in here, I need to give this left tail over here to the calculator, all right? Of course, as well, I need to give this information, include this information to the calculator, all right? So let's get into it. So for the calculator, the option that I'm going to be using here, I'm going to go to second and vars in order to enter the distributions. And what is going to happen here, I am using the inverse normal. So inverse normal, you are putting the area and getting the value back. So enter. So the area that I'm going to use is 0.05.05. The mean, remember, is this one. The mean right now is 3850, 3850, and the standard deviation is going to be 615 divided by radical 53. So 615 divided by square root, which is second and squares here, 53, and that's all. And paste, enter, and the value that you're looking for, so this is the lower value, which is 3711. I need to round it to the closest number, so this is going to be my answer, 3711. Now, in order to get the second value, which is this one, I need to feed to the calculator the whole area, the left side area from here to here. All right. So this area, all right, this new area, all right, probably I should use a different color. As you can see, is 0.90, all right, plus this value here, plus this tail here. So the total area in here is going to be equals to 0.90 plus 0.05. Okay, and this is going to be 0.95. So this is the left area that I need to feed it to the calculator. Everything else stays the same. So I'm going to do exactly the same thing. Second, vars, go to inverse normal, enter, and that's the only thing that you're going to change. You're going to become 0.95, and everything else is the same. Paste, enter, and that's going to give you the value 3988, which 0.95 whenever you round it is 89. So this is the second value here. All right. Okay, so let's go and plug it in and see whether the work is correct or not. To the nearest whole number, it's fine. So here you're going to be 3711, and here you're going to be 3989. Check the answer. Okay, that's great. Now, the second question. So a daycare wanna charge a low tuition, so the lowest possible, and I guess here they want to meet the 90% confidence interval, the 90% of their population. What would be the lowest end here? And you need to pay attention to this sentence, nearest 100, right? So you want to round your answer to nearest 100. So if I round 3711 to nearest 100, it would be 3700, 3700, and let's check it. And that's correct. All right, that's all.